our course information, we can go to the mesacc.edu website, and in the upper left you'll see Canvas. Canvas, oh, it jumped into my my screen already. That wasn't quite already logged in. Well, what would I expected? I was expecting the login screen. You put in your MEID and password into that login screen, it will take you to the dashboard. And on the dashboard, then you can click to the class, and that will take you to this page, which was where I was hoping to end up. All right, so like I said, for the online and hybrid, if you are comfortable in that environment, set aside the time, do the exercises, you can follow the videos, and come to class when you have questions or need that face-to-face instruction. All right, so I went through and kind of my thoughts on the modeling. I will let you read all that and let me know if if you have any questions. Basically, jumping down to do this, we have the getting set up, textbook information, course information, and contact information. Because not everybody checks their maricopa.edu email every day or as much as you would your standard Gmail. I do ask that you give me a contact and let me know if you want me to use it all the time or just when needed. Under the Gmail Maricopa Gmail system, you can go into the settings and forward your email. So for this semester, maybe forward it to an email that you use regularly, and then after the semester's over, turn it off and log into it every once in a while. All of the information, don't really want to make all of that public, but this is where you're going to find the download site, the site license information that you'll put into when you go to do the install. As far as the install, it's somewhere between 7 and 12 gig of data, so you'll need a high-speed connection to download it. I think I downloaded it on my slow DSL. Took about 4 hours at about 10 megabits per second. Today at 80 or 90 at work was more along the lines of about 30 minutes. So depends on which module you download and what you need. I do have it available on a flash drive. If you have a 16 gig flash drive, you can take the software and we'll copy it directly over, so you don't have to do a download at all. So a couple of options there. I think 2016 is still available. So given the choice, SOLIDWORKS 2017 is preferred. The education versions are coming out around the end of July, first part of August. So we'll see SOLIDWORKS 2018 over the summer. Getting to work, the modules list or the assignment list. One of those will make sense to you, or maybe both of them. I kind of go for the assignment list. The modules list maybe has a little more information. Being able to go through what we're going through now, and then the regular assignments. Again, there are going to be 2 tracks. There are going to be 2 tracks for this for the group, and you can pick which track you want to proceed with. So this is the standard track. I haven't really figured out how I'm going to integrate that second track into the assignment list. All right, on the assignments page is a little more streamlined, just the items that you're looking at. Each of these will go to a page. So looking at Chapter 1, instructions of what you're going to do. And because this is kind of a really condensed window, I put the Chapter 1, Part 1 into a larger page format and give you a few instructions, let you know what what information is going to be important, if there are mistakes in the drawings. And that's one of the reasons why I do like the book is you have to look at these drawings. There are going to be some missing dimensions. Maybe there's a dimension that doesn't make sense. In the real world, you don't get perfect dimensions. And in the real world, you're pulling this stuff out of your imagination, and you get no dimensions. You're making them up as you go along. So that portion of it is par for the course. All right, so then you'll get a sheet. When we get over to the syllabus, you will I'll have the information on the textbooks for these drawings. So just kind of running through the instructions. Then the YouTube videos. So the fall of 2017 is at this point the most concise. If you find something that doesn't make sense, or maybe want to watch another explanation, or maybe I said it a little different the semester before, then you can go to the fall of 2016. The spring of 2017 was kind of like this semester. I picked a vice and I fought it, and I had battles with dimensions and making things work, and it was a good exercise in something that I haven't seen before. So that's my concern, is that these exercises and assignments, I've done them for about 7 or 8 years now, and I can probably do most of them with my eyes closed, or at least with fingers on the keyboard. So to keep it fresh and new and offer alternative media, that's where I'm going for the track 2. So did I leave it in here? At one point I had on one of these, when you take a look at these, don't panic. All right, we're going to take this systematically and go through piece by piece. So I mentioned earlier that at the beginning of class, if you're on the standard assignment track, track 1, going through, watching the videos, doing the exercises, and pretty much going step by step, then I'll take those questions at the beginning of class, and then we'll also have lab time to address any issues that you're finding with those projects. Track 2 then is pulling up something that looks a little more horrendous, and this is kind of what happens in industry. Is you start off with a little piece and it snowballs into this great big avalanche of work, and you take it step by step, piece by piece, until you get through it. If I plan this right, if my best guess was right, this is going to be about the same amount of parts, drawings, and assemblies that you would do in track 1. All right, so I'm not trying to make more work, but being able to look through the system, go through the process, address the issues in the project. With this one being a complete assembly, I'm also hoping that we'll be able to do some simulation. Put the FEA on it and say, let's see where this thing breaks. How does it deform? All right, that's something I haven't had a lot of time to do previously. So there's 2 or 3 pages of that. The other thing is design for manufacture. This is I want to see this, well, this was from the 2004, maybe 2014, 2014 version of technical drawing. Technical drawing goes back into I think the 30s. And these first, I have to double check, but I want to say about the 6th or 7th dimension or edition is when started seeing this particular assembly. I'll jump back to the home. And then, so the intention is to take each of those parts, build sub-assemblies, and from the very beginning, and maybe not concentrating so much on the parts, but on the process. All right, parts, assemblies, drawings, taking all of those steps. And, again, it's going to depend on your learning style. It's going to depend on your comfort level with all of this geometry and all of this new software. Yes? You said it was a textbook? Yes. We'll jump over into the syllabus after we'll kind of get to the bottom here. Let's see. And then, so kind of the intention, 5 or 6 weeks maybe on project that track 2, and I've always just liked this one. It looks way more complicated than it is, but again, part of it's looking through the drawings, looking through all of those dimensions, coming up with a strategy and building it. All right. So I just kind of thought of what I'm not prepared for is mixing track 1 and track 2 at this point. So don't know how to handle that one just yet. And then there is the robot arm that is on the welding station. I think it's in, what would that be, 106? 107? Anyway, over here in the manufacturing lab, they have the FANUC multi-axis, 5-axis robot arm that actuates the weld head. And so I have that zip, and when you bring in a converted file into the assembly, it's not going to have mates. Everything may be in position, and I need to grab a snapshot of it and put it up there for a little more information, but everything may be in position, but it doesn't work. If you go to move something, you just kind of throw it out into space, and it's not doing what its intention. So that's kind of a end of the semester project where we can put those together, start to look at the motion, and go through taking something that is existing and put the mate relations on it, get something usable out of it. The short course was one of the comments that came out of last semester was the CSWA, that if you are focused on taking the CSWA exam at the end of the semester, that one of the big issues is speed. All right, so the videos, the things that I do at the very beginning, and the pace that I set is still a little on the fast side, but it's not as fast as you need to be for the CSWA, and definitely not as fast for the CSWP. So the Associate's exam, Certified SolidWorks Associate, and the Certified SolidWorks Professional, they're pretty good indicators of your skill set at the end of the semester. So my intention was the short course was 94, actually a few more than that, but 94 models in about 8 hours. All right, so not throttled back, push the buttons, a little bit of explanation of what I'm doing, why I'm doing it, and I called it just for fun. All right, so if you see these, you go out to the YouTube site, you're going to see all of those listed first because they were uploaded last. And the playlists are what you're going to want to focus on so that you get to the 2017 fall playlist or the 2016 fall playlist. All right. Let's see. And then as far as track 2, I guess I need to clarify that. Track 2, that pretty much is, you get through all of that, that is your final exam. Having a set of working drawings and all of that geometry. I'm not going to beat you up too hard on taking the CSWA. On the other side of it, you'll be very well prepared for the CSWA, whichever track. It's a matter of, it's an online test. The format is a little weird. Sitting down and having a time test as an exam is always a little disconcerting. Taking the exam gets you the points, pass or fail. All right, so I'm going to say take it, see how you do, find out where your strengths and weaknesses are, and then have that certification in your pocket when you leave here. Let's see the YouTube references. There's a lot of good information. There's a lot of misinformation on YouTube. So I tried to pick out some videos from other sources that you might want to look at. Put those under the references. And then under mysolidworks.com, I don't see the link, but there are videos available from SolidWorks website as well. The 3D printing, and then from Interlink, which hosts our the SolidWorks user group meetings. They handed out the line card with some shortcuts, so we'll start talking about shortcuts pretty soon. The threads, my take on threads as the machining manufacturing background, threads are going to be everywhere. Mechanical fasteners are in your future if you stay with the design and design elements. So knowing a little bit about threads, not getting tripped up on nomenclature, on the jargon associated to it, is a big plus. And even as we go into 3D printing, I just kind of jumped past up a couple. You're still going to have to prepare for threads. Most of the 3D printing might be able to snap fit together or something that you want to glue, but most of the time I still plan on bolting my 3D printed parts together, because at this point, the speed, the accuracy, all of those things that I need for a production part aren't quite there. For a prototype, it's great. I can do some complex geometry and put it together, and yeah, this is going to work. And as soon as I put a significant load on it, snap. I've broken more 3D printed parts thinking that I put enough fill and enough structure into it, only to find out that, yeah, it was really a great prototype, but I still need to make it out of aluminum, out of Delrin, out of poly, whatever. So the threads need to still be incorporated. And I've printed the minor diameters of the thread holes and then gone back and tapped and gotten really good results. So knowing this basic information, having something to start, even if we have to drill it out, is a good way to go. The common file locations and extensions on number 10. We'll get to those as we get into the options and things that are going on in the background. Try not to overwhelm you too much, but it's kind of inevitable that you're going to see a lot of those parameters that, just everything you never wanted to know about what's going on in the background. All right, so coming over to the syllabus page or to the setup, I'll just jump into the syllabus. I need to make sure that this link works. So under the syllabus is the course summary, and then the website, and we can go to the course information. The textbook will be under that under the 266 class. So this is what district has me put in. As far as the overview, we'll hit the high points. Again, I don't necessarily want to read the whole web page to you, but basically you can turn in your assignments through Canvas, which is what most people do. We'll go through the process of zipping up those files and uploading, which is going to be a lot more effective than upload one, click the next one, upload, click the next one, upload. If you are comfortable with Google Drive, I will have to double check, but the Maricopa Gmail and Drive did not allow for syncing directly. So there's a way to share it to your personal Gmail account, which you can sync to your hard drive, and it pushes around, but it's more complicated than it's worth. I do it with your assignments because I've beat on it enough to figure it out. And, each one of you will get a folder, and whatever you turn in Canvas or whatever you decide to put in from Gmail, there'll be a repository of all of that information. All right, so, and then I haven't had anybody hand me a stack of papers in probably long enough that I can't remember. All right, so at least maybe 10 years. So we're closer to paperless, all electronic exercises and assignments. I will say that I do not go through and nitpick every line, arc, and circle that you draw. What I'm looking for, we'll get into, but I'm looking for just kind of the gross errors. Something's really wrong here. You missed something. Where can I point you in the right direction? Let's see. The CNC programming or the other classes that I teach, full of terminology. It's like learning a new language. It's okay to get frustrated. I say that a couple of times. In the introduction, I mentioned that none of these are meant to be torture devices. That, you have probably 10 or 15 minutes. If you're spending more than that on a particular exercise, go on to the next exercise. Let something click. Let your mind go through that process and problem solve. All right, and then if you're still not getting it, that's when you come to class, ask the questions. Let me point you in the right direction. Let's see, all of the programs are visually intensive, lots of icons, little things going on the screen. Your ME ID and password were on that page that didn't quite pop up when we went into Canvas. Again, some of this is for students that are looking to sign up as much as the information that you need having been signed up. Basic computer skills. We have the full student version. And I need to take out the purchase. We're providing that with the class fees. Standard grading. Let's see, parking IDs. Where to find information. Again, the student handbook is probably one of those. If you have insomnia, it's a great place to cure your insomnia. Kind of like I tell everybody, my YouTube videos, just put on a YouTube video. I'll put you to sleep in half hour or so. Let's see. Standard policies, registration. If I sent you to the years program, they would go solid what? So nothing against them, but we're kind of in a niche here. Is we're not really in that gen ed group, but it is part of the process. Disability services. Contact information if you need to request some kind of accommodation. You will talk to disability services, and they will send me information of what I can provide and do for you. So there's their information. Attendance is taken through Canvas. So logging into Canvas regularly, seeing that progress, uploading your parts and your files, that basically counts as attendance. All right, so work comes up, family related comes up, and you miss the class, pick it up on the videos, turn in the assignments, and keep moving along with the process. And again, I know that I'm going kind of fast through this, so take a moment to go back over it and let me know if you have any questions. So, lecture start times, I mentioned that we'll take the regular assignments, the track 1 assignments, and I'll answer questions at the beginning of class, maybe 10 or 15 minutes, and then plan on about an hour going into the track 2 items are going to be my focus. Right, so, updating the material on YouTube. Let's see. Also, there are videos. Well, they're now 2 or 3 years old, so you probably won't encounter them up front. But surfacing, weldments, sheet metal, all of those get into various degrees, and depending on your level of interest and what you're doing with it in industry, you'll be able to find something on just about everything. Academic honesty. You may and should use all resources available to complete the assignments. Ask questions of me and your fellow students. Do your own work. The only thing that I ask is this is a challenging process. The drawing, getting the visualization skills, I can tell you what buttons to push, but you have to develop the visual skills, being able to imagine it and know what tools to put it on the screen. If you are eligible for the Honors Achievement, that's a great program to get into, and provides kind of a scholarship or towards your classes. We do a little bit of discussions. I need to do more discussions, but whenever I say discussions on Canvas, everybody kind of goes, discussions, So we'll put in the introductions, and I'll show you where to find those. But you have a wealth of experience even in the students in this class. People have all come from different backgrounds, different industries, and knowing helps me to know where to direct my attention. If there's kind of a comment, if it's a little bit wider on the topics, then I take that wider stance. So the netiquette: read all posts before responding, and reread your content for appropriateness and tone. If opinions differ, the agree to disagree, and messages containing hateful speech or harassment will not be tolerated. I will shut it down. Social media. I have social medias. It's up to you how much you want to use it. Sometimes I'm heavy into the social media, but for the most part, I check it once a month or once a semester. Kind of not regularly. It's kind of one of those, gets to be a little time consuming, and just don't really have the time for it. And our privacy policy, again, with the videos being recorded. Respect your privacy, but be aware that your voice, we're not taking videos, so it's not pictures or anything, but your voice might be re-recorded in the video. And then viewing of material on the internet that is in questionable taste and may be offensive to others isn't a good idea in the classroom setting. Cell phones, tells you how old this is. Cell phones and pagers to viber off. Calls may be taken outside of class. Use your own best judgment. And a little bit of the course matrix at the end of where different items fit in to the overall mix. Any questions on course info? Ton of information in 30 seconds. No quiz. Let's see. Get back to home. So solid modeling. I thought I had the. Okay. Don't know where that went. GTC 266 solid modeling. All right, so specific to this class then. Seems like every semester district sends me another paragraph to include in my syllabus. And also I wanted to mention, if you want a print copy of this, we can either send it to the printer, or you're welcome to print it out from home. But again, that's another stack of paper that really don't want to go through if I don't have to. Location, you found your way here. Face-to-face lecture about 4:30 to 6, and open lab will be about 6 to 7. So class runs till 7. This semester I don't have anything scheduled after. You usually have the CAM class run 7 to 9:50, and so if you need that extra time, I don't mind staying a little late, but I'm not staying till 10. And then our course dates are from today through about the second week of May. Let's see, online components again for people that just find this site, but also to have another means of access. So the YouTube, I think I made the comment that if you just go directly to the YouTube site, you'll have access to all of those videos as public. But again, make sure to log into Canvas every so often so that I see that you are, you're able to find your way there or participating on the Canvas side of things. So course information we just did. My contact information. Because of the web bots, I let it go through the J. Lacey Tech, which is this website. There are a couple of other emails that probably showed up in Canvas, and you're welcome to use those. Again, with the online hybrid blended, I think I've covered that maybe enough, but how do I say it? I'm not running you off, but the face-to-face is not as high a priority to me as it once was. Right, so if you are comfortable in the online hybrid blended, whatever the buzzword of the day is, you're welcome to take advantage of that. I have had plenty of people tell me that they just don't have the discipline. If they don't come to class, they won't get it done. All right, so you know yourself better than anybody. You take advantage of and work with the program the way it suits you. Time commitment, our lecture and lab, and the hour to hour and a half. Schedule enough time, and that scheduling time here, lab time, and outside of class. Give yourself enough time to complete, and then towards the end of the semester, it's not so much as a crunch. And it just kind of depends on the first lectures I broke up into like 20-minute segments, and then I did half-hour segments, and then I just let them run. There's hasn't really been a lot of feedback that said one was better than the other, so most of the time I just let them run. The advantage is that in class I don't so much have a pause button. On the videos, hitting pause, rewind, listen to it again, follow the process. Maybe I went too fast across the screen picking buttons. That gives you a good opportunity to review that information. Textbook is for track 1 then is Engineering, Design, and Graphics with SolidWorks. The ISBN numbers available from Amazon. The 2010 version and I think the 2011 versions are around less than $10 with $5 in shipping. So on a budget, kind of go towards the older books. What we're using these for is there is enough information in the chapters, explanation and going through the process, and the author has more of an AutoCAD background, so there is a different approach or slightly different approach going on with the text. But there are a good amount of models to go through, and it's that repetition that is going to build you up through the process the quickest. There is a 2016 version. Of course, it will be the most expensive at about $100. Budget accordingly. Yes?
Is there any real big difference between those?
Nope. No. I think 2014 they added a little bit more loft and sweep on a couple of projects, but probably 90% the same. So if you happen to get the 2014 book and it's a little different than the lectures, the 2 or 3 that were different are not a big deal. They weren't the models, the projects weren't complicated enough, so I haven't caught up to them. Actually, I keep kind of spacing them, really. So I can go back and catch those models and make sure that we get a video on the overlooked, so to speak. I have not seen the 2016 version, so I can't really speak to 2016. It's been out for 2 or 3 months. Well, 2 or 3 months since I knew it was out, and I just haven't gotten around to ordering it or looking for it. So we'll be using the SolidWorks 2017, and all the class computers got 2017 installed, so that part's looking pretty good. The software is not backwards compatible, so last semester it was 2016 with student version 2017. You could do work here, put it into your 2017 at home, but then you couldn't bring it back into class, so that's always a headache. So the USB media of choice, we won't generate a gig, so just about anything that you have, putting it on your cell phone even, if you don't mind plugging that in. The files don't get horrendously big, let's put it that way. So Google Drive has about 5 gig of storage. But there again, because we can't sync, you're doing a lot of uploading, downloading from your class. So make sure you understand Google Drive before you jump into to that. It is a good strategy, but it has its limitations. All of them have their limitations. So we are going to produce solid models, parts, assemblies, and drawings. Okay, so semicolon, parts, assemblies, and drawings. Editing as I go. Sketching, applying relations, and creating features to generate parts. Whichever track we go through, we're going to hit a lot of relations. The parametric portion of solid modeling is what's really driving and gives us the horsepower. that we don't have to dimension everything, that we can utilize those relations, that we can utilize the structure of the geometry and build out our parts in a fairly quick, very accurate form. And then I have not looked at the prerequisites. Oh yeah, and then the assemblies. Basically, all the terminology that we're doing in the parts, as far as relations, carries over into the assemblies and is also used again for those relations. And then the drawings, because of the associativity between those modules, we're basically picking up our parts and assemblies, dropping them in the drawing, and telling the drawing what to do. So lots of terminology, and I'm really big on relations. Relations to me is a foundation as much as being able to draw a line, a circle, an arc. Understanding those relations, being able to read those symbols, that's a foundational component for me. And then stable parts are fully defined sketches. So we don't have things left hanging that can move accidentally. And the design intent, we'll talk about the magic crystal ball of design intent. What is this part going to do for me in 2 days, 2 months, 2 years? Am I going to be able to reuse it? Will I ever reuse it? And that's going to drive some of my decision-making processes. Engineering data, so basic measurements, mass properties, center of mass, moments of inertia. We can extract all of that out of the geometry. And then add-ins, so photo rendering, animation, simulation, CAM software, all lives inside of SOLIDWORKS as an add-in. Still working on the collaborative environment. I think I just about have the PDM, and I saw that the PDM client was installed. We'll probably end up turning that off because I don't have the network structure in here. It would be really great to be able to check in, check out of the vault within the classroom setting. I don't know what that would take, but if I can get it on my laptop and get it installed correctly, that's something that you will encounter in industry. And so document management for PDM. Assignments we detailed, and we kind of ran through those. 10 parts per week, 10 to 12, and they gain in complexity with Chapter 3 being the most complex. Chapter 3 has 48 or 49 projects in it. We take the middle section, we take the beginning section, we skip a section, and then we do the end section. So you're still doing about 12 models each, but not so complex that it's kind of out of the scope of the class. When you get to that level of complexity, switch over to the short course and take on the full chapter 4, which is going to be drawings. And then more online resources, not required, but take a look at Solid Professor. They send out weekly tricks and tips, and kind of a handy resource to know that it's available and that it exists. Standard disclaimer, information included in the syllabus subject to change. I will notify you in Canvas by an announcement or by emails. Yes? Okay, sure. All right, we'll do that when we finish up here. Let's see, the curriculum. So starting the terminology, this is just a quick overview of the screen. What is this? 2013. All right, so this isn't ancient, but it's aging. Starting in on the terminology, work areas, my mind map of everything kind of connected to everything else, and then getting into the particular tools, functions, and basically the jargon of creating a model. All right, so lots of terminology. This is a good place to start with picking up some of that terminology. And then let's jump over to the gallery. So just to give you some ideas, we will do a translation the raster to vector conversion from a JPEG or PNG into a model, and then this is the older logo. So the logo on the YouTube videos currently was released last fall. So probably need to update that picture before I get in trouble for it. Some of the cam profiles, that was a master cam, a little hard to see on the screen. One of the projects that we did for several semesters was the 5-piston, basically 5-piston airplane rotary engine, and animating that so that it moved and all of the pistons did what they were supposed to do. It was pretty cool. And then running it through the photo rendering. And also a little bit hard to see, but this was a raster to vector conversion and then engraved in aluminum. So the MCC Thunderbird. The school mace was kind of a multi-project. I had a special project student that I converted the geometry from the picture, and he made all of the solid model, different levels and layers. And then this ended up being, because this was electrograde copper, with your pencil lead is a little bit bigger than the end mill. So that 1/64th, 15,000ths, not quite half a millimeter. End mill, I think the biggest end mill was just under a millimeter at a 32nd 030 diameter. And the 15,000ths ended up being 1.2 million lines of code and ran in 28 hours. So this is over in the CTL, was put into a very nice wood that one of our retiring instructors was woodworker. He made the base, and that was turned out quite nice. And then I went through it about the 2014. I went through the golf ball stage. So coming up with different dimples, different patterns on the golf balls. Also went through my soda bottle phase, surfacing, creating decals, labels, filling up the bottle with a liquid volume and determining, wow, how close to 500 milliliters or 2 liters or 750 milliliters can we get? Again, extracting that engineering data, coming up with basic information. Then a couple of drawings. And then I went through a dodecahedron phase. I will bring in the 3D prints that we did of the dodecahedrons because they turned out and actually yielded some really good information about the critical angles where the droop, where it starts to fall off as it's moving up those interior-exterior angles. Sheet metal. So converted the dodecahedron to sheet metal and unfolded it. So don't know that I could fold it up and weld it, but it looks cool. And then, of course, if you have a dodecahedron, you have to have a icosahedron. Our 6 degrees of freedom. When we get over to the assemblies, you have movement in X, in Y, and in Z, and then rotation about each of the axes. So those are our constraints when we're dealing with the assemblies. If it's a static assembly, all of those will be constrained. If it's dynamic, then one or more will be allowed to maintain its motion, maintain its movement. This was a 3D sketch. It started out to kind of be a turbine blade, but didn't quite make it. But it looked cool. So sketch-driven patterns, curve-driven patterns, so bubbles and the glass. One of the projects from the first CAM classes was the hook, and getting that profile to blend smoothly through the lofts and guide curves, kind of a challenge. Standard sweep is springs or threads. If you use those as your base geometry, that will get you through kind of the concepts. And then compound curves, joined curves, interlocking, toroidals, basically intersecting surfaces and finding curves at the intersection of those surfaces. A couple of different items, and then sweep with guide curves. So basically the ellipse going through the path with guide curves determining how it bulges and which way it bulges. And then the same thing with a loft. We have a triangle going to a circle to the octagon, back to an ellipse, and the guide curve kind of determines how it bulges and which way it goes. 3D sketch. Then one of the very first top-down assemblies that I did for the class, where if you change the size of the axles or the basic shape, then everything updated and followed along. So multi-body modeling and top-down assembly are advanced concepts, but I think that inside of the track 2, there will be several opportunities to pick up some of the standard bottom-up assembly, top-down assembly, and multi-body. And then one of the machine projects we did, well, that's been a long time ago. Piece of acrylic for was a vacuum gripper, and had a LED backlit array so that we could pick up wafers and present them to a industrial camera to do the inspection, and the LEDs had to be able to go through the gripper with minimal amount of shadow. So that was the finish from the tool coming off the machine. That was no polish, no flame, no nothing. A couple more sweeps and revolves, circular patterns, and then equations, sine and cosine, intersect, and other than that, it just makes my eyes twitch. Also, that was my first attempt at putting colors on them and trying to get that whole magic eye thing, get the depth going, so had a little too much fun there. All right, so I'm going to go ahead and stop.